Hi, welcome back to the shop. This is part 5 in our series of videos that's all about jigs and fixtures. And as you may remember in the last video, well, we just completed our pocketing operation and we ended... Oh, wait, sorry, I'm very sorry to stop it here, but I just want to answer a question I received about our last video, the part 4 video. And the question was, why do you not use coolant when you're pocketing the jig? Well, the answer is three-pronged. First, well, this is a piece of free machining steel. That means that it's a steel that cuts very, very easily. And if it cuts easily, that means that pressure is reduced and heat is reduced as well. Second reason, this pocket is quite small. So I'm not really going to be machining long enough for it to become a problem. And well, the third reason, this is more practical for me, is because I don't want to have to clean up the mess. So that's my reasoning. If you want to learn more about coolants and, well, cutting oils, check out this video. Here's a link to that. And now we can get back to today's video. And we ended up with this, what's starting to look like a very sexy little jig. Okay, so we have our clearance holes just to open up the corners and something else we'll see in a minute. But right now, this side internal here and this internal side there are going to be my reference sides. I don't want to forget about those sides, so what I'm going to do is I'm going to identify them with two very minute prick punch marks. So as you can see, my pin is coming along quite well. Now, it's a work in progress, mainly because I forgot to turn the camera on to film that first side. Now, I got this piece of brass out of my scrap box. It's not long enough to make a 3/4 plug without flipping the part over. So what I'm going to do here is I just turn one end to the proper diameter, and I'll hold it by that diameter and come and finish the second end. What's nice with the second end is I can set my scale to 0 and I won't have to measure again. I'll just come back to the 0 I had on the other side. So there are my surfaces. That's the hole I want to plug in. I've just pushed it in place lightly, and I'm going to use the vise here to press it in final. There you go, a nice brass plug. So my pin is in the jig. Now, what's that pin for? Well, first off, let's say it didn't have to be brass. I made it in brass just because it looks pretty good. Whenever you can incorporate a piece of brass into a project, well, it kind of gives it a touch of class. Now what this is really is a foolproofing pin. It's a pin that stops you from making a mistake when inserting your part into the jig. In other words, it makes it so that the part fits only one way. And that's because of this angle on the part. So if we set it down here, you can see that if I orient it as I want it to, it fits in readily. And if I try to put it another way, it will not fit in any other way than the proper way. Another thing here, I've incorporated the pin into a feature that was already there. So I didn't have to do anything except for produce the pin and press it in place. And that, well, saves time. So when you plan things out, you can figure to use an entity that's existing already on the part. And, well, like I said, saves some time. So let's move on to our work holding devices. So I have pretty well everything that I need here to do the drilling and tapping operation. I have my height gauge here with the scriber tip, and well, you may wonder why the block here, or my jig, is sitting on a 1, 2, 3 block. It's because this height gauge with the scriber tip can't really go under 1 inch in height. So just to be able to measure under 1 inch, because I'm going to be scribing a line at 3/8 of an inch from the top of this, actually it'll be flipped over when I do that, well, I bolster it on a 1 inch block, so that makes everything even out. So I have my block. I want to lay out a line in the center of the 3/8 depth, so at 3/16 down from this edge here, and in the center in this part, and in the center in this part here, so that I can install 2 screws that are going to push the part against the 2 reference surfaces. Remember, the surfaces adjacent to that brass pin that I put in, well, are my reference surfaces. So once that I've laid out those lines, these holes don't have to be particularly accurate. So all we're going to do is prick punch, center drill, just with a very small tip, drill with my tap drill size, and tap the holes. Now the screws that I've chosen are these, and they're 1032 screws. And I've chosen these screws, well, because the thread is quite fine, and that helps when you want to torque things down just with your fingers, finger tight. A fine thread will do better than a coarse thread. And also the head size is pretty well what I want, because I want the head here to be smaller than the depth of my pocket. And that way, when the screw is in the center height of the pocket, the head will be lower than the surface that has to sit on the drill press table. We'll see that at the very end. So let's get with the layout work. I've set my height gauge to 3/16 of an inch, or if you prefer, half the depth of the pocket. And well, I can lay out my 2 lines. First will be here, and the second will be on this end. As you can see, I've applied a little blue there just to make those lines pop a little more. Now, I'm going to want to turn sideways and do the 2 other lines. For tapping, we're going to use this very simple tap block. Now, we have a project where we produce a much more complex tap block, but for this we're just going to use this simple one, and it's just a piece of brass that's been surfaced on each end and drilled through with a hole that is just slightly larger than the diameter of the tap that I want to use. And that'll permit to put that on there, and when I insert the tap in there and hold it with my fingers, it aligns the tap properly for threading a nice perpendicular thread. Now, remember, I never said that this was going to be exciting. We can just carry on now with the other threaded hole in the same manner. If 40 years of marriage has taught me anything, it's that I'm not perfect. Now, if I look at the reference surfaces on my part as far as the part's drawing goes and not the jig, my references are here and there. That means that this screw is pushing the part against its reference, and that's what I want. But this screw isn't. It should actually be on this side. I'll have to go and fix that. So the problem has been fixed. I plugged that hole up with a flathead screw that's flush so that there's no possible confusion. And well, here are my two final work holding screws. So my part fits in. I snug down the first screw, tighten down the second, finger tight only, and tighten down the first. And well, we're ready to drill, but our drill bushings aren't there. And that's what we need to do now, is go and produce the holes for the drill bushings. If we get back to our part drawing, we notice that the holes that I want to drill here are spaced by 1/2 of an inch. We also notice that both holes don't have the same reference. The second hole, this one here, is referenced off of the first hole. And our first hole is referenced from the secondary reference surface and the tertiary reference surface. You may also have noticed that the dimensions have different tolerances. First off, the hole diameters, well, it's 1/4 inch with 2 decimal points, so that's plus or minus 5. That's a range of 10,000ths of an inch, and honestly, drilling is good enough. We won't have to ream these two holes. Now, the center to center distance, that means the distance from the center of one hole to the other, regardless of their diameter, as long as they're within their tolerance, has to be 1/2 inch plus or minus 1 thou. And that's because there's 3 decimal points. And in the part 2 of this series of videos, well, we determined that our tolerances would be plus or minus 5 for 2 decimal dimensions and plus or minus 1 for 3 decimal dimensions. So we have 2 holes to produce. And before we go any further, I think there's one thing that I've forgotten to mention up to now. We're drilling the holes in the jig, not in the part. And that means that the holes in the part may be 1/4 inch, but the holes in this jig are going to be bigger because they have to accept a bushing that's going to accept a 1/4 inch drill to drill the holes in the part. So we're going to be aiming for 1/2 inch here. So we have 2 holes, and well, they have to be separated very accurately, but not positioned very accurately as far as the original reference surfaces go. How could I go about that? Well, we usually say don't make things any more accurate than they have to, and I think you've seen many examples of that in this project that we're working on here. But in this case, it's not always true, because if we went the simplest, it would be to lay out, punch, center drill, drill and ream the first 1/2 inch hole, the one that refers back to the 2 edges. Once that hole existed, well, I could indicate that hole, put my spindle directly on center of the hole, and then move from there over to the second hole using the collets, graduated collars, and well, getting that spacing properly. If I wanted to go really crazy, I could do the same thing with some Joe blocks to make sure that I've got a very accurate movement. But we'll just go with the lead screw here, and we'll hope we get it good enough. We'll see. So that's one way, but indicating that hole is a bit of a pain. So even though I don't need to edge find the inside of the pocket that I've produced to produce that first hole, I'm going to have to line that pocket up if I want the second one to be properly positioned. So if the surface of the pocket isn't square with the movement of the table, nothing here is going to work. So saying that, it is, as far as I'm concerned, a little more complicated to indicate a hole, set yourself to 0, and then move over. I would prefer, if possible, and it's going to be a little less accurate maybe, but I would prefer to edge find, move to the first hole. I have to edge find anyway, so what will edge find, move to the first hole, because if I do, well, edge find, I have to find the edge of the hole or the edge of the pocket, one or the other. So edge find the two surfaces, move to the first hole, drill and ream that hole, move to the second hole, drill, bore and ream that second hole. Why did I say drill, bore and ream? I could have drill, bored and reamed the first one too. That would make it even more accurate. But once I get to that second hole and it's drilled, bored and reamed, it's going to be more accurate because drills have a tendency to wander at least somewhat. Well, if I go and position the second hole with a center drill, it may wander very lightly. So when I drill and ream the hole, it might be in its position that's not quite on its center. So if I drill smaller than I would normally drill pre-reamer, I would then bore with a boring head to bring the hole round. But when we're doing small holes like that, it's hard to bore and get a real accurate diameter. It's a lot simpler to drill, bore to bring everything back on center, and then ream, because I know the reamer is going to follow the hole that's there. And if I wanted it to be deadly accurate, I would drill, ream, and bore the first hole, indicate that first hole, set myself to 0, and then move to the second one, and drill, ream, and drill, bore, and ream that second hole. For us, we're just going to keep it simple. We're going to edge find our two surfaces, and we have a video about edge finding if you're not sure what I'm talking about. Then I'm going to move to the first hole, drill and ream it, set myself to 0, and move to the second hole, and I'm just going to drill and ream that second hole. We should be within, I'm hoping, the spread of 0.02 of an inch tolerance that I have, plus or minus 1. But none of this can happen if I'm not oriented properly. And well, that means that I'm going to have to line up this part in my vise. Be careful here. You'll note that I'm aligning the part. I don't really care where my vise is as far as alignment goes. What matters to me is the reference surface that I'm using on the part. Is it going to be aligned with the axis of the table? And that's why, you'll see in a second, that I'm going to indicate the surface inside the pocket and not the vise itself. Sometimes I just can't shut up, and well, this is about the proper length for me. I'm pooped, and I'm going to head outside first off to check my sugar or maple water buckets to see how that's doing, and then to head down home and rest a little before supper. That means that next time we'll be edge finding. Now we've lined up, we're properly aligned. We're going to edge find. We're going to position ourselves on the reference 0 to make the first hole. So, and then we're going to move over and do that first hole, and then we'll move over and do the second hole. Once that's done, well, I'm way too cheap. I'm lazy and I'm cheap, so I'm way too cheap to go out and buy some drill bushings. I mean, this is just a fictitious thing. I'm going to make 8 parts and that's the end of it. I'm not making 2,000 of them. So I'll produce my own drill bushings, maybe even in bronze, just to make things interesting. We'll see. But that'll be in our next video. So until then, have fun. Be safe. Don't work if you're too tired. And happy machining.